I would like to thank ISRS and the committee organizers for inviting us to speak. The topic and the title of our research is the effect of anterior corneal higher order aberration ablation depth on primary topography-guided LASIK outcomes. We have no financial interest. Contoura topography-guided software uses anterior corneal higher order Zernike coefficients from the high-resolution Placido Vario scan to generate an ablation profile. The measured anterior corneal higher order aberrations are directly correlated to the HOA ablation depth. Here is an example of the anterior corneal HOA ablation map on a Contoura treatment screen. Contoura also measures the anterior corneal astigmatism and allows the surgeon to modify, enter, and treat any magnitude or axis of astigmatism desired. Subjective clinical manifest refractive astigmatism, RA, is what we measure with a 4-opter exam. It includes all sources of astigmatism from cornea to brain. The topography measured anterior corneal astigmatism, ACA, is what the Contoura topographer tells us. It measures and includes only the anterior corneal surface. These two can be different, as shown here, and this difference vectorially is called ocular residual astigmatism, or ORA. There can be a difference in both the axis or the magnitude of astigmatism. The bigger the difference, the higher the ORA. The various optics of the eye can contribute to this difference, including the posterior cornea, the lens, and the brain. Now, what is the impact of anterior corneal HOAs on ORA? Several surgeons assume that the cause of ORA is due to the presence of anterior corneal HOAs that affect the subjective refraction. They claim that pre-op corneal coma can express as subjective refractive cylinder, and therefore treating the full manifest can induce new cylinder. Treating and removing anterior corneal HOAs might result in post-op surprises when treating the full MR cylinder. And this asymmetric nature of the HOA ablation on the cornea, especially if deep, may induce a refractive effect. However, these assumptions come from observations stemming from highly aberrated corneas with pathology. Does this hold true in primary healthy eyes with a lower range of aberrations? We previously published on the role of anterior corneal HOAs showing contribution of anterior corneal coma to ocular residual astigmatism in 37,000 eyes. We found that the magnitude of anterior corneal coma does not correlate with that of ORA or to subjective refractive astigmatism. Coma is against the rule in 28%, while ORA is against the rule in 86% of eyes, with no correlation between coma and ORA axis. Therefore, coma cannot explain the difference between subjective refractive astigmatism and topography measured anterior corneal astigmatism. These findings disprove the assumptions that many surgeons still have. With evidence that HOAs do not impact subjective refraction in primary healthy eyes, we set out to determine if treating the subjective refraction would lead to different outcomes in deep versus shallow HOA ablation depth eyes. We see here how HOA ablation depth is an indicator of the degree of irregularity on the anterior cornea, since it is calculated from the amount of anterior corneal HOAs. We treated all eyes with the subjective refractive astigmatism as the input and not topography corneal sill. Eyes with naturally occurring irregular astigmatism or high amounts of HOAs were not excluded. The distribution of the HOA ablation depth shows how few eyes have high ablation values. 83% were less than 10 microns, and only 1.8% have more than 15 microns. As expected, we found a strong direct correlation between anterior corneal HOAs and HOA ablation depth. This makes sense, as this is what the technology measures and treats. There was no clinically meaningful correlation between the preoperative HOA ablation depth and postoperative sphere, cylinder, and SEC. This confirms that ablation depth does not influence outcomes and accounts for less than 1% of any outcomes variation. We used a tercile split for comparison since statistically it allows optimal sample size and effect size. The third of eyes with the shallowest HOA ablation depth, on average 5 microns, were compared to the third of eyes with the deepest with an average of 11 microns. Deep eyes had over twofold greater HOAs and coma than shallow eyes. We found fewer deep HOA eyes achieved 20/20, but of note, there were fewer 20/20 pre-op eyes to start with in this group. The efficacy was therefore identical, as was safety. UDVA within one line of CDVA was also similar. For accuracy, SEC within half and 1 diopter were identical. 3% more deep eyes had post-op cylinder of 0.75 diopters or greater, but the pre-op incidence of high cylinder was almost twice that of the shallow group, with a 30% greater pre-op cyl magnitude average. This is what explains this higher outlier rate in the deep group. We found that the deeper the pre-op HOA ablation depth, the greater the likelihood of higher pre-op cylinder magnitude, showing a direct linear relationship. Why are high cylinder eyes more likely to get an outlier of 0.75 diopters cyl or greater post-op? For the same angle of error post-op, which both deep and shallow groups had, a high cylinder eye will lead to a larger absolute post-op magnitude error. We also found a marginally higher retreatment rate in the deep group, although both were below 1%, again due to the deep group's higher cylinder magnitude pre-op, with HOA ablation depth having no correlation to outcomes. Matching pre-op cylinder in both groups, the retreat rate becomes the same. We looked at relative risk and found that high cylinder was 1.6 times as likely than deep HOA ablation depth to result in an outlier outcome. Very deep eyes with ablation depth of 15 microns or greater, 82% achieved 20/20 and 90% were within a half a diopter of intended plano cylinder. It's a similar outcome to the subset of eyes with cylinder greater than 2 diopters in the FDA study. In summary, HOA ablation depth directly correlates to anterior corneal HOAs. Almost all pre-op eyes had shallow to moderate depth. We found excellent efficacy, accuracy, and safety in both deep and shallow groups, and the impact of HOA ablation depth on post-op outcomes is negligible in healthy virgin eyes. Deep HOA ablation depth directly correlates to greater pre-op cylinder. Very deep eyes showed lesser outcomes, but were similar to what is seen with higher pre-op cylinder eyes. Deep and very deep HOA ablation depth eyes should not be excluded from topography-guided surgery, and we should treat these eyes using the subjective refraction as input in Contoura. Anterior corneal HOAs do not impact post-op outcomes. Our findings support the premise that pre-op anterior corneal HOAs do not influence the pre-op refractive astigmatism treated, unlike in keratoconus and highly aberrated corneas. Treating on the subjective refractive astigmatism gives excellent outcomes, even in eyes with deep HOA ablation profiles. Our surgeon group has treated over 130,000 Contoura eyes with refractive astigmatism as the input. Over 40,000 eyes have been contributed to the current literature. In addition, there is significant published evidence on refractive astigmatism treated outcomes that further adds validity to our findings. Our take-home message is to treat on the subjective refractive astigmatism as input for topography-guided Contoura eyes. Thank you.